Okay, we're jumping all the way back to chapter 7, bone tissue. And this is slide 2, bone, two types, compact, spongy. We're also going to be looking at cartilage also. Um, hyaline cartilage and fibrocartilage, and, uh, and of course, ligaments and tendons as well. Most people, when they think of bone, they think of it as like a framework, thing to hang organs off of and attach muscles to. But actually, it's metabolically extremely active tissue. It's very vascular. That means it has lots and lots of blood vessels. And it has lots of functions besides the obvious one, first one on the list, support. But of course, the blood cell formation, hemopoietic tissue in red bone marrow where all the blood cells are made. A calcium homeostasis. It's a huge reservoir for calcium to make sure your blood calcium stays constant. And of course, it allows movement, of course, um, by muscles attachment and moving bones. And it provides protection. It protects your brain, for example. It protects your heart. And there's a little bit of acid-base balance there too, because when uh, bone is essentially acid calcium phosphate salts, and phosphates are really serious intracellular buffer. Remember the nature of bone tissue, it's a connective tissue with a solid matrix. Remember, the way we classify connective tissues are often by what is the nature of the matrix. Made up of collagen, which is a protein, with a calcium phosphate salt called hydroxyapatite. And then we're going to look at shapes of bones. Long bones in your extremities, short bones in wrists and ankles, flat bones in skull, and some irregular bones. Some really oddly shaped bones, which include some skull bones and vertebra. This is slide 5. Here's these shapes of bone. Again, flat bones in the skull, irregular bones, vertebrae, long bones in legs, short bones in your feet and hands. So we're going to talk about, as I mentioned, compact bone and spongy bone. And spongy bone is something that's called diplo when it's in the middle of your flat skull bones. We're going to find out that compact bone and spongy bone are found in different places on bone. In some of these places, different names. The diaphysis is and as far as a long bone, is the middle of the bone, and the epiphysis is the end of the bone. Then we have articular cartilages. At the end of all of long bones, for example, there's cartilage, and you form joints at the end of where two bones come together. There's a periosteum, which is dense irregular connective tissue on the outside of bone. And endosteum, which I think is a simple squamous epithelium on the inside of bone. And then we're going to talk about what are called epiphyseal plates, which are layers of cartilage that allow us to grow taller and that close up at puberty. And then we're going to talk about a lot about different kinds of bone cells, different kinds of bone cells and what they do. Here's slide 7, which shows a long bone and the epiphysis, where we have spongy bone, and here's the epiphyseal line, which used to be the epiphyseal plate, and then the endosteum on the inside, the periosteum on the outside, certain things called perforating fibers, and a nutrient artery that goes into the bone, and the articular cartilages. And here we're going to talk about certain in the next video, we'll talk about the blood cells, osteocytes, osteoclasts, osteoblasts, and osteoprogenitors. Osteo is the prefix that means bone. And here is a layer of compact bone, where you have the osteocytes with the mature bone cells in lacuna that's in these lamellae that are found in compact bone. And these little lines between them are called colliculi, and this is how bone cells communicate with each other and where nutrients and oxygen and carbon dioxide move. This is slide 8. More anatomy. Compact bone has these eversion systems, which are these circular mellae with a central vein inside. Spongy bone has spicules and trabeculae. It's got big spaces between it. And bone marrow, red bone marrow, remember, is blood cell formation found in the epiphysis, in the epiphyses. Yellow is in the diaphysis, and that's just fat.